Hello everyone, I hope you're all doing well. In this video, we're going to solve question 4 of chapter 2, physics 1. In this question, there are two cars. There's a red car and there's a green car. And we do know the distance between them. So the question has given us the distance. It is 220 meters, okay? And we do know that the red car has a constant velocity. So the red car moves with constant velocity. And the green car moves with constant acceleration. Okay, these are given by the question. Okay, and the question is giving us two different scenarios for which we know the velocity of the red car and we know where these two cars will meet each other or pass each other, okay? And eventually, by giving those two scenarios, the question is asking us to obtain the initial velocity of the green car and its constant acceleration, the value of its constant acceleration. Okay, now before solving the problem, let's just remind ourselves what is the equation of the position in terms of time for constant velocity. Okay, for constant velocity, we can write x position in terms of t, okay, equals to, this is for the constant velocity, equals to the velocity times delta t, or t minus t naught, okay, plus x naught, okay. Now, this is the equation for constant velocity. This is just a generic equation, doesn't have to do anything with this question, okay. For the constant acceleration, what do we know for constant acceleration? So this was for the constant velocity, okay. We have this, and for constant acceleration, the equation becomes xt equals to 1/2 acceleration t minus t naught squared plus v naught, meaning that the velocity in its initial condition, initial time, times t minus t naught plus x naught. Okay, as you can see, if you plug a, like if you change a to 0, this term will vanish and these two will be the same, which makes sense because acceleration equals to 0 means constant velocity. Okay, now this is for the constant velocity equation. So we have constant velocity equation, sorry, constant acceleration equation, and we have the constant velocity equation here. Okay, now let's use them to analyze what's happening in our problem now. For the red car, I can say that the position of the red car, so I can say x position of the red car, t, equals to velocity of the red car, t minus t naught. In our question, let's assume that we start at the initial state, the time is 0, okay? So it's just gonna be VRT plus x naught. Now, what is the initial position of the red car? If you assume that this is the origin of the axis, you can say that this is x equals to 0, okay? So by doing this, we can say that the initial position of the red car is actually 0. So it's just gonna be VR times t. This is okay, VR times t, but this is xr in terms of t, so please don't confuse these two. xrt means that the position of r in terms of t, it's not a multiplication, but here I'm saying that vr times t, okay, plus initial position, which is going to be 0. So this is the equation of the red car. Again, this is not a multiplication. And for the green car, using this equation, I can say that for the green car, the position of the green car equals to 1/2 acceleration of the green car. Again, t naught is 0, so it's going to be t squared plus the initial velocity of the green car, the vg naught, okay, times t plus initial position of the green car. What is the initial position of the green car? Well, based on this figure here, it seems like as if the position of the green car is 220 meters to the right of the origin, so it's positive 220. Okay, now we have obtained the symbolic equation for the position of the red car and the position of the green car. Okay, now let's read the question. The question states that if, let me just bring up the question again. Okay, it says that if the velocity of the red car, okay, equals to 20 kilometers per hour, then what's going to happen is that at a certain time, at t equals to tp1, which we have no idea what this time is, but let's just say at a certain time t equals to tp1, then what's going to happen is that the position of the red car at tp1 will be equal to the position of the green car at tp1, and they're both are going to be equal to 44.5. Because the question is saying that when the velocity of the red car is 20 kilometers per hour, then these cars will pass each other at x equals to 44.5. Passing each other means that at that certain time, their positions will be the same, okay? So at t equals to this time, the position of the red car will be the same as the position of the green car, and they'll both be equal to 44.5. Now, I can actually use these two equations to expand this. So I can say that if I plug this here, then I can say that 44.5, looking at the equation of the red car, would be equal to the velocity of the red car, which is actually given to us. It is 20 kilometers per hour. To make sure that I'm consistent in terms of units, I'm gonna actually convert it into meters per second. So it's going to be 20 VR, but converting it into meters per second requires me to multiply this by 1000 to account for conversion between kilometers to meters. And for hour, each hour is 3,600 seconds, so it's going to be 3,600 here. So this is just the velocity times t, and t equals to tp1. Okay, so the first, writing this for the red car, I can get this equation, and writing it for the green car, I can have again 44.5. Now looking at this equation, the green car, why is it p? It should be g. Okay, the green car equals to 1/2 the acceleration of the green car, which actually I don't know. So remember that what we're trying to do is to obtain the acceleration of the green car and the initial velocity of the green car. So these are the two unknowns that the question is looking for. 1/2 ag t squared, I'm just writing this again, plus vg naught, and instead of t I have to write tp1 times vg0 tp1 plus 220. Okay, so what I did was that I expanded this equation by using these two. These are the two equations that I have. Now this is what I get from the first case. So this was the first case. Okay, now let's move to the second case, and the question stating that if the velocity of the red car is actually equal to 40 kilometers per hour, what's going to happen is that at a certain time, at t equals to, let's call it tp2, the time that the cars will pass in the second case, okay, what's going to happen is that xr tp2, the position of r, the position of the red car at t equals to tp2 will be equal to the position of the green car at tp2, and it's going to be equal to, based on the question, 76.6. okay, so this is the second case that the question is describing. And again, using the similar thing that I did here, I can write position of the red car at this time, which is 76.6. Again, I'm using this equation, equals to the velocity of the red car, which is given to us, 4t, and I have to convert it into meters per second, so I have to multiply it by 1000 and divide it by 3600, okay, times TP2, okay, and we can write the same thing for the green car, 76.6 equals to here 1/2 acceleration of the green car, now TP2 squared plus the velocity of the green car in its initial condition at the beginning times TP2, okay, and then plus x naught, which is 220. Okay, now let's see, we have one equation, two equations, 3, 4. So we have, in total, we have four equations, okay? And let's see how many unknowns do we have. Well, we have TP1 is unknown. I've already counted TP1 here. We have AG, this is another unknown. VG naught is another unknown. And we have TP2 is also another unknown. So we have four equations and 4 unknowns, okay? 4 equations, 4 unknowns. Okay, since the number of equations and the number of unknowns are equal to each other, we can hope to be able to solve for all of these unknowns. Let's see if we can do it actually. From the first equation, actually I can obtain TP1 by just rearranging this equation, because in this equation the only unknown is TP1. From this first equation, I can get if I do the math, if I just rearrange this, I will obtain TP1 is equal to, let's see what's the value here. Yeah, TP1 is equal to 8.01 seconds, okay? Very simple. All you need to do is to just divide everything by this number, and then you can isolate it for TP1. Okay, now from this, now that I've obtained TP1, I can plug it into this equation and obtain, and just reduce this equation to, let's see, it's gonna be, let's see, if I just plug it here, it's gonna be 44.5 plus 1/2 AG. Instead of TP1, now I can write 8.01 squared plus VG naught, which is again unknown, times TP1, which I've obtained here, 8.01 plus 220, okay? Let's just leave it as it is right now here. So this equation will turn into this equation by using this. And what about this equation? Similar to this, I can actually obtain TP2 from this equation by just rearranging it, because the only unknown here is TP2. So if I do that, the TP2 will be equal to approximately 6.89 seconds. Okay, again, what I did was I just rearranged this. So we're obtaining that using this equation. Okay, from this equation we can obtain this. Now let's see the last equation here. Again, I have TP2 here, so I can plug this here. So we would have 76.6 plus 1/2, sorry, equals to 1/2 AG TP2. So TP2, we've obtained it already, 6.89 squared plus VG naught, 6.89, because TP2 equals to 6.89 plus 220. Okay, now if you look at these two equations, now we have two equations and two unknowns here. which is a very common like system of equations that we've seen a lot of times. If I rearrange this and eliminate, what I can do is that I can eliminate AG from this equation, from the first equation now. I can write just, I'm just going to isolate for VG naught. I can write VG naught as equals to 44.5. If I do the math here, it's just going to be minus 32.08 divided by 08 AG divided by 8.01. Okay, by just rearranging this equation, I can obtain VG naught in terms of AG like so. Okay, now if I plug it into this equation, I will just have an equation in terms of AG, because VG naught will disappear and it will just replaced by AG. And if I do the math here, if I just, using these two equations now, I can obtain AG is equal to minus, I think I obtain minus 2 meters per square seconds. Okay, now that I obtained the AG, I can plug it into this equation and obtain VG naught as minus 13.9 meters per second. Okay, and that's it. Just so you know, after we obtained these 4 equations, the rest was just math. So it's not physics anymore. We just solved a math question, a 4 equation and 4 unknown. So the main challenge was to use the information given by the question to obtain these 4 equations. If these are clear to you, then the rest is just math. You can do the math yourself.